Okay, so in this video, we show you what's the meaning of order and also linearity. Okay, order. Okay, so the order of the differential equation is the order of the highest derivative. Okay, that appear in the equation. Okay, so what's the mean by order here is the order of the highest derivative. So the keyword here is the highest derivative that appear in the equation. Okay, I hope that you can differentiate between the derivative and also the power. Okay, make sure you can differentiate between these two. Power is not the order. Okay, so the order is the highest derivative that appears in the equation. Okay, for example, you have an equation of dx dt plus 2 dx dt equal to 0. Okay, so my question, okay, for now, my question is about order. Okay, it's not relate with the ODE, PDE and so on. I mean, even though actually you can find out lah, this is ODE or PDE and so on. But for this part, or for in this video, I will highlight on, or I will focus on the order. Okay, so back to the meaning. Okay, the order is the highest derivative. Okay, derivative, pembezaan not power. It's a derivative. So dx dt, dx dt. So you can see between these two, what's the order? Also, what's the derivative involved here? Is this the first derivative, right? dx dt. Okay, you need to differentiate lah. Kalau dx dt is the first derivative. If d square x d square, so means that this is the second derivative. If this is d cube, dt cube, so means that this is the third derivative. Okay, so for this equation dx dt, so means that these two involve with only one derivative. Therefore, this is a first order. Okay, why first order? Because the highest derivative that involved in this equation is only one. Okay, alright. Okay, I give you another one example. So let's say you have d square f dx square plus 2x df dx equal to sine x. Okay, so this part or this term, the highest derivative or the derivative for this one is second derivative. Okay, second derivative. This is first derivative. So the highest derivative that involved in this equation is 2, right? Second. So therefore, this equation is second order. Okay, this equation is second order. Okay, last one. I give you example. Last one. The example d cube y dx square minus dy dx 4 plus 4x equal to 0. So this term, the derivative that involved here is third derivative. Okay, third derivative. How about this one? Okay, this number 4 is not the derivative. This is power. Okay, you can differentiate between these two. This is how we write the derivative, but this one is not derivative. This is a power. Okay, power. So what's the order for this equation? Fourth order? No. If your answer is fourth order, so that means wrong. Back to the meaning of the order. The order of the equation must be the highest derivative that appear. So this is derivative, this is power. Even though this is a more than 3, which is 4 is the higher than 3, but this is power, not derivative. So therefore, for this one is a third order. Okay, so make sure you clear on it. Okay, you can differentiate between power and also the derivative. Okay, right. So now, okay, we proceed to the The last one, which is the linearity. Okay, the linearity. Okay, so when you get the equation, you need to determine whether that equation is linear or non-linear. Okay, linear or non-linear. Okay, so the meaning of the the meaning for linearity is okay, linearity. So linear equation are defined as those in which the dependent, the keyword here dependent variable, and their derivative do not occur as product raised to power or non-linear functions. Okay, so this is the meaning of a linear equation are defined as those in which the dependent. Okay, the keyword here is dependent, dependent and also and their derivative. Okay, do not occur as a product. Okay, this is the first one. Must be not a raised to power and also non-linear. So maksudnya ada 3. They have a 3 condition to make it the equation linear. So this first one must be do not occur as a product. Okay, product between what? Between dependent and also dependent. Maksudnya dia kat sini variable involved ataupun kita perlu fokus on dependent. Independent tak kisah dia nak product ke apa, tak kisah. Okay, it must be dependent. Okay, and then the dependent also cannot be raised to power. Maksudnya tak boleh lebih pada power 1. The power, the higher power, the keyword is not power. The keyword here is power, not derivative. Okay, the power must be only 1. And the last one is must be a non-linear. It cannot be involved with non-linear function lah. Okay, non-linear function is something like we know that exponential, tangent, sine. Okay, that is non-linear function. Okay, so this is the meaning. Okay, this is the meaning, and then you need to highlight or you need to focus on the dependent variable, and then must be these 3 fulfill. So then kalau fulfill baru dikatakan equation tu adalah linear. Okay, if not, it's a non-linear. Okay. Okay, for example, okay, I give you an example on this linearity. Okay, let's say you have equation dx dt minus 3d dx dt equals 0. Okay, so the first thing first is you need to identify the dependent variable. Okay, dependent variable okay, macam saya cakap before this in the previous video, dependent variable kalau nak senang yang berada di atas lah. Okay, so dependent variable is x here. Okay, so now you dah identify your dependent variable. Now check between the 3 condition just now. Kita ada 3 condition tadi. So the first one, the dependent variable cannot be occur as a product. Okay, you can see that this is dependent, this is independent. Okay, independent T kat sini bawah, so is independent. So product between dependent and independent is okay, tak ada masalah. So condition number 1 okay. Okay, then power must be only 1, cannot be more than 1. Okay, you can see for this term the power is 1 lah, kat sini power dia 1. How about this one? Okay, this one the power is 2, right? Okay, kat sini power dia 2. So automatically this is a non-linear. Automatic this is a non-linear because, okay, kenapa? Because of the power is more than 1. Okay, right. Okay, so next example, let's say you have d square x dt square minus x dx dt equal to 0. Okay, equal to 0. Right. So you can check for the first term. The first term, is it okay or not? Okay, your dependent variable here is x. Okay, so this is a not product between any dependent, so it's okay. And then the power is 1. Okay, you can see here the power is 1. This is derivative. So derivative okay, tak ada masalah. Ini check power, and then power is 1, so okay. And then this is a linear function. Okay, now we proceed to the second term. The second term, this is dependent variable. So now dependent variable multiply with dependent variable. Is it okay or not? It's not okay, right? So the condition number 1 is must be do not occur as a product between dependent. So tidak berlaku yang darab antara dua ni. Therefore this is non-linear. Okay, this is a non-linear. Okay, the last one. Okay, for example, you have 3dx dt plus tangent x equal to 0. So we check the dependent variable here is x. Okay, so the first term here, the first term is multiplication between x and 3. 3 is a constant, so it's okay. Okay, it's okay, right? And then the power is also 1. Okay, so it's okay, and this is the linear equation. Okay, now we proceed to the second term. The second term is tangent x. Okay, tangent x is a non-linear function. Tangent x, sin x, cos x, exponential, that one is a non-linear function. And because of this one means that this equation is non-linear. Okay, so here is the example of a non-linear. Alright, okay, so for now we are finished on chapter 1. Because chapter 1 is so basic, is you need to know what's the ODE, PPA, what's the order, linear, and so on. So I hope that you can do the tutorial. Okay, I will upload the tutorial question later on in Ulearn, so you can use or you can answer it. Okay, right, so see you next topic. Okay, next topic means maybe next week lah. Alright.